Well, I'm here in my electorate office with Dr Jeremy Henson, who's a cancer researcher. Jeremy, thanks for coming and have a chat.
Thank you very much. I really appreciate your interest in our work.
Now, Jeremy, you're pursuing a line of inquiry in relation to cancer, which you first started going down doing your PhD over 10 years ago.
Yes, 14 years ago now. Time moves fast. It was an idea I had while working in this field that it really needed a specific molecule. We're dealing with things that we can't see, so we really need a way of measuring it, and I was really making life difficult doing research in the field without having a measure.
So let me understand that. You, while doing your PhD, said, well, I think there could be something here. You went out on a limb, as it were, and said, let's go and see if we can find it, and you went and looked for it and you found it.
Yes.
And just explain to me how that molecule is going to help in curing a particular cancer.
One of the things we want to do with new cancer treatments is to make them very specific for cancer. We don't want to harm the patient. So the problem is that a lot of the standard treatments target dividing cells, which isn't all that specific. It's definitive for cancer, but it's not specific for cancer because normal cells divide as well. So there's a lot of acute side effects, and there's also a lot of long-term side effects for survivors. So what we need to do to be able to create more effective cures and cures that won't harm patients is to target properties that cancer cells have that normal cells don't have.
So this could be a much more efficient way of identifying and putting into practice particular drugs that will block particular cancers.
The opportunity here is that we've got a mechanism where this has never been able to be done before because there was no way to measure it. And now we've got the technology to actually measure it.
So this sounds like quite an important breakthrough. You've been working on it for many years. You've got a lab at UNSW,
yes.
But it sounds like you've got quite a way to go yet.
Yes, everything takes a long time in science. I've been working on this particular project for about 5 years. So I've got a new lab with mega resources. The more resources you have, the faster you can go. But we're getting close.
Well, it sounds very exciting, and part of your challenge is continuing to secure funding, yes, to keep the work going.
Well, this project doesn't secure any funding because it's not publishing papers. So it can get a bit difficult to follow the big picture and wanting to actually make a difference for patients rather than doing what you need to do to survive in science, and that's churn out papers.
Yeah. Now, I recently saw a video that you did on a crowdfunding website, essentially seeking funding support from anybody who's interested in your research, and we'll put a link to that on the video. So if you're looking at this now, you should see the link. And if you've got an interest in supporting Jeremy's work, please go to that link. So Jeremy, good luck. It sounds like potentially a pretty important breakthrough, but it's been a lot of hard work to get to this point and a fair bit of hard work yet to go.
Yes, I think it's going to be a really important breakthrough. I'm very excited about it.
Terrific. Well, good luck with it, and thanks for coming in to have a chat.
Thank you very much.